This podcast is about how to write chemical equations given if you have enough information to do that. So there's a couple things to remember when we write chemical equations. Some of these we're already familiar with, some of them are new. The reactants are on the left and the products are on the right, and in between we write an arrow, which we sort of treat as an equal sign, but it's not. The other things you have to remember, if you have enough information to know the state, then you have to say whether it's a solid, a liquid, a gas, or if it's aqueous, which means it's soluble in water, it's dissolved in water. And then make sure that the equation is balanced when you're finished. And another way to check this is to make sure that your formulas are written correctly. So a couple more formulas that we haven't done. We've talked a little bit about this in bonding, but now you're expected to remember that there are 7 diatomic elements, which are hydrogen, nitrogen, oxygen, and then the 4 halogens. And one mnemonic to help you remember this is hey with a capital H, no halogens. And the capitals are the diatomics. So H for hydrogen, N for nitrogen, O for oxygen, and then the halogens. And remember that fluorine and chlorine and the halogens are gases, bromine is a liquid, and iodine is a solid. And just so that you have it in your notes, there are a couple other elements, namely phosphorus, which actually comes as a group of 4. It makes this sort of structure with 4 phosphorus together. And then sulfur comes in a ring with 6 sometimes, and sometimes it doesn't. You are not expected to remember these, but I just wanted to have them in your notes in case you need them later. So diatomic elements are always bonded in pairs when they're in their natural state. Okay, so acid formulas are written. There's 2 basic types of acid formulas. One thing to know about acids is they always start with a hydrogen, and we call the hydrogen a proton. It's H+, it acts like a cation. It's not quite a cation, but it acts like a cation. We treat it like a cation. We write formulas just like we would with any other cation. And then for acid names, we take the ending and we change it to ic, followed by the word acid. So the first type is halogen acids. We'll start with HCl, and they start with hydro. Be really careful, only put hydro in the halogen acids. So chloride would make hydrochloric. Again, we change the ending to IC. Acid. You probably know hydrochloric acid. It's a pretty common acid. So use that pattern in hydrochloric acid to help you remember the other halogen acids. Bromine makes hydrobromic acid. Iodine makes hydroiodic acid. And fluorine makes hydrofluoric acid. The polyatomic acids that you need to know are here, and they come from the polyatomic groups, again, with a proton. The first one is HNO3. We know it's an acid because it starts with an H. So NO3 is a nitrate group. So the acid made with this is nitric acid. So again, change the ending to IC followed by acid. SO4 is the sulfate group, and it's going to need 2 protons because it's a -2, and the acid that it makes is sulfuric acid. They throw the R in there probably because it's easier to say. And similarly, PO4 is the phosphate ion, and then it makes phosphoric acid. And lastly, C2H3O2 with a -1 is the acetate, and it makes acetic acid. So those are the acids. So in this next section, I want you to stop the recording, go through and take the words that you're given and turn it into a chemical equation, a balanced chemical equation. Use just formulas. Make sure to add the states if you know them, and check your formulas and then balance it when you're done. So here we were given a word, a sentence. Aluminum metal reacts with chlorine gas to form solid aluminum chloride. So we're going to turn that into a chemical equation. So checking this, aluminum, solid aluminum, which is a metal. Chlorine gas, remember that chlorine is diatomic, so we need the 2 here for the chlorine. It's a gas, and it reacts with chlorine gas to form aluminum chloride, which is a solid. And then when all the formulas are correct, then go through and add the coefficients, the 2 for aluminum chloride, the 3 for chlorine gas, and the 2 for aluminum metal. We add those numbers at the very end to balance the equation. So shut off the recording, go through and finish it, and then turn it back on to check your work. So a couple things to keep in mind. Water, if you're not given the state, then you assume that it's in its natural state at room temperature, which is a liquid. And then hydrogen you're told is a gas, but you're expected to know that that's a gas also. Octane is found in gasoline, so we know that that's a liquid, but you're usually given that information. And then this is a typical combustion reaction, and the numbers get pretty big. And in order to make it balance with whole numbers, we got to put the 2 here, and then that gives us 25 oxygen molecules. And the last one, hydrochloric acid plus sodium hydroxide, it's already balanced when all the formulas are done, so we don't need any coefficients for that one. So for the next section, you're given balanced equations, and you write a word equation for that. One typo that's here, the P in Na3PO4, this should be a B to match the B over here. So you probably want to fix that. So when you write these out, you want to not use any formulas, just use actual real sentences and make them complete.